Area of composite figures. A composite figure is a figure which consists of two or more geometric shapes. In these next two lessons, we will be finding the area, and sometimes the perimeter, of two-dimensional composite figures. Please feel free to pause your video at any time to write down the information. When finding composite area, we can add the areas of parts together or subtract the area of parts away. So let's start with adding parts together. We want to look at this figure, and this figure is not like any that we have on our reference material for STAR. So we want to take line segments and break up our composite figure in order to find the area. Pause your video and see if you can come up with a few ways to find geometric shapes. One picture that I noticed is by taking the area of a triangle. I can see the area of a rectangle, and here I can see half of a circle or a semicircle. Another option is to break your figure into a trapezoid, a rectangle, and again another semicircle. Either one of these ways is going to help give you the area of the composite figure. Now we're going to describe in words how to find the area. We want to find the area of our triangle, our rectangle, and find the area of our circle. We want to make sure we divide our circle by 2 because it is a semicircle. After that, we're going to add the 3 separate areas together to form our composite figure. Please pause your video now to find the area of your separate pieces. When we're looking for composite area or area in general, we always want to make sure we want to start by writing down our formulas. So area of a triangle is 1/2 base times height, plus we're going to find the area of the rectangle, which is base times height. The area of our triangle is pi r squared, and since this is a semicircle, we're going to go ahead and divide by 2. Now let's plug in our measurements. The base is 4 and the height is 3 on my triangle. So 3 times 4 is 12. Half of 12 is 6. My rectangle is 1, 2, 3, 4, 5 long, and 1, 2, 3, 4, 5, 6 tall. 6 times 5 gives me an area of 30. My circle has a radius of 3. When I square 3, I get 9. I can take 9 times an approximation of pi and just use 3, which is 27. Since this is a semicircle, I will divide that by 2, and I get 13.5. Your last step is to take all 3 of these areas and add them together to get the whole geometric figure. When finding composite area, we can add the areas or subtract them away. Now we're going to look at a subtraction example. Describe in words how to find the approximate area of the shaded region. Our shaded regions look very similar to triangles. They have both a base and a height, but with this rounded corner on each one, we won't be able to use the area of a triangle formula. We notice that there are 2 shapes. I see both a square and a circle. So to find the shaded region, I find the area of the square and subtract the area of the circle from the square. Go ahead and pause your video to find the area of the circle and the square and then subtract them. We want to make sure we write our formulas down. So to begin with, the area of this square is base times height. The area of my circle is pi r squared. In this problem, we will not be dividing our circle by 2 because we have a whole circle. I'm going to plug in my numbers. The base is 8 and the height is 8. The radius of the circle is 4 squared times 3. Take 64. 4 squared is 16 times 3 is 48. Then I'm going to subtract the 2. The area of the shaded region would be 16 units squared.